about your syllabus. So today's our topic is Laplace transform. So first I would to inform you what is the weightage of Laplace transform. So for the GTU end semester exam, 14 marks weightage for Laplace transform. So it is very important chapter in mathematics 2. First you need to understand the definition of Laplace transform. Let f of t be a function defined for all t greater than or equal to 0. Then Laplace transform of f of t is defined by L of ft. This definition is very important. So basically Laplace transform is a particular form of integration. You have to remember this formula. When you want to find out the Laplace transform of any function, you can take integration 0 to infinity e raised to minus st f of t dt, and it is denoted by f bar s. Now there are important 7 formulas in Laplace transform, so try to remember. First, Laplace of 1 is 1 by s. If you want to find out the Laplace of 2, so what will be the Laplace of 2? It is 2 by s. For particular example, for Laplace of 5, so as we know that Laplace is a linear transformation, so we can take 5 common and then find out the Laplace of 1. So it will be 5 by s. Now Laplace of e raised to at is 1 upon s minus a. Is 1 upon s minus a. So what is the Laplace of e raised to 2t? You can write 1 by s minus 2. Laplace of sine at is a upon s square plus a square. Now I will take particular example, Laplace of sine 3t. What is Laplace of sine 3t as was this formula? It is 3 by s square plus 9. Laplace of cos 80 is s upon s square plus a square. So Laplace of cos 40 is s by s square plus 16. Similarly, you can find out the Laplace of sine h80 and cos h80. So you can see the difference between sine 80, Laplace of sine 80 and Laplace of sine h80. Okay, here it is plus and here in denominator it is minus. Same way in cos, in Laplace of cos 80 s upon s square plus a square, but in Laplace of cos h80 s upon s square minus a square. If I am asking Laplace of sine h9t, so you can write 9 by s square minus 81. Okay, cos h5t, so you can write s upon s square minus 25. Okay, now one last formula of Laplace transform, which is also very important for the polynomial function. Laplace of t raised to n, so it is depend upon n. If n is rational number, so it is n factorial gamma n plus 1 by s raised to n plus 1, and if n is integer, then n factorial by s raised to n plus 1. Let me take particular example, Laplace of t raised to 4. So now compare with our formula. What is n? N is 4, so you can apply this formula, n factorial by s raised to n plus 1. So n is 4, so you can write 4 factorial by s raised to 5. Further you can simplify, 4 factorial is 24 divided by s raised to 5. If you want to find out the Laplace of t raised to 3 by 2. So what is Laplace of t raised to 3 by 2? As per this formula, first you need to check the power of t, 3 by 2, which is rational. So try to use this formula, because this formula is n factorial is not defined rational number. So you can write gamma 5 by 2 by s raised to 5 by 2. Now what is gamma 5 by 2? You can reduce, this was the chapter in mathematics 1. So gamma 5 by 2 can be reduced further by this formula, which is important formula of gamma function, gamma n plus 1 and gamma n by the property of gamma function. So we can use this formula to reduce this gamma function, 3 by 2 gamma 3 by 2. But gamma 3 by 2 can be written by this formula 1 by 2 gamma 1 by 2. Okay, and gamma 1 by 2 is root pi. Okay, so final answer is 3 by 4 root pi by s raised to 5 by 2. Okay, so we can apply this formula on t raised to 3 by 2. Same way, if it is t raised to Laplace of t raised to 5 by 2, so we can write gamma 7 by 2 by s raised to 7 by 2. Okay, and by use of property of gamma function, we can reduce further. Also, I want to mention here one important property of gamma function. First property, second property, you can write gamma 1 by 2 is root pi. Okay, now let's move on next question. Now think about Laplace of t square plus sine 4t. Now Laplace is linear transformation, so we can apply Laplace transform on individual function. So first you can write Laplace of t square plus Laplace of sine 4t. Now what is Laplace of t square? As per this formula, 7 number formula, n factorial by s raised to n plus 1, where n is 2. So 2 factorial by s raised to 3. And Laplace of sine 4t. What is Laplace of sine 80? A upon s square plus a square. So Laplace of sine 4t is 4 by s square plus 16. Okay. Now move on next topic. Next question. Laplace of sine square t. How to find out the Laplace of sine square t? Think about it. So Laplace is, as we know that Laplace is a one type of integration, particular form of integration. So first, whenever you are in confusion, so you just think about the integration. How to take the integration of sine square t? What you will do? So you will apply one trigonometric formula, sine square theta is equal to 1 minus cos 2 theta by 2. So same way we can apply this formula to reduce the power of sine, 1 minus cos 2t divided by 2, and then as per the linearity property, because Laplace is linear function, so we can apply on individual function. Laplace of 1 minus Laplace of cos 2t. Laplace of 1 is 1 by s, and Laplace of cos 2t, s by s square plus 4. Now third question. Now think about this case, 2 sine 3t into cos 2t. How to take the Laplace of this function? Here it is the product of two functions, two trigonometric function, right? So simply we cannot apply Laplace transform of sine and cos, but we have to think about the property. So first we need to separate these two functions. So we have various formula to separate the function. 2sc. What is 2sc? 2sc is s plus s. So Laplace of 2 sine 3t into cos 2t, we will apply this trigonometric formula, sine 5t plus sine t. Now you can apply Laplace on individual term, Laplace sine 5t plus Laplace of sine t. Laplace of sine 5t is 5 by s square plus 25, and Laplace of sine t is 1 by s square plus 1. Clear? Let's move on next question. Think about Laplace of e raised to 2t minus 1 whole square. So we can apply Laplace of e raised to 2t directly because this is the square of this function. So first we have to simplify. Laplace of e raised to 4t minus 2 plus 1 to e raised to 2t. Okay. Now, as for the linearity, we can apply Laplace on usual term. 2 of Laplace of e raised to 2t plus Laplace of 1. Okay. Laplace of e raised to 4t is 1 by 1 upon, you can refer the previous list of the formulas. Also I have already signed you Laplace of e raised to at is 1 upon s minus a. So here is Laplace of e raised to 4t, s minus 4 minus 2 constant, and Laplace of e raised to 2t as same like this formula, s minus 2, and Laplace of 1 is very simple, 1 upon s. Okay. So these are the basic questions of the Laplace transform. Now let's move on. First method, which is very important in Laplace transform, which is known as first shifting theorem. What is first shifting theorem? If L of ft is f bar s, already I have a mention in definition, Laplace of ft is denoted by f bar s, then Laplace of e raised to at f of t is f bar s, and then we will apply shifting theorem, s tends to s minus a, then finally it will be f bar of s minus a. Okay, this is the formula of shifting theorem. This way we can apply shifting on function. So let's take particular example. Okay, this is the formula. We will apply this formula. So Laplace of e raised to 2t cos 3t. So first, in which case we can apply the shifting theorem? If it is a product of two functions of t and one function is exponential, so you can apply shifting theorem. In this case you can apply. Okay. Now how to apply the Laplace transform? So as per the definition, first you need to take the Laplace of ft, which is known as f bar s. Okay, and then we will apply shifting. So here compare with this formula and identify what is f of t. So e raised to at, e raised to 2t is there, ft is this, so cos 3t is f of t. So first think about cos 3t. What is Laplace of cos 3t? S by s square plus 9. So f bar is this. Now we will apply shifting. S tends to s minus a, but here in this particular case a is 2. Now one last step and you will get your final answer. Just replace s by s minus t, s minus 2. So this is very important theorem, first shifting theorem. Let's take another example. Laplace of e raised to minus 3t and t raised to 3. How to find out the Laplace of e raised to minus 3t into t raised to 3? Again, this is the product of two functions of t and one function is exponential. So yes, we can apply shifting theorem. Now compare with this shifting theorem and identify what is f of t. F of t is t raised to 3. So find out the Laplace of t raised to 3. What is Laplace of t raised to 3? You can refer formula 7, t raised to n, where n is integer, n factorial by s raised to n plus 1. So 3 factorial by s raised to 4. Okay, this is the Laplace of f of t and it is denoted by f bar s. Okay, now one last step, we will move on to shifting. S tends to s minus a, but a is 3, a is minus 3. So here we have to write down s plus 3. Okay, because minus is already there and a is negative again. So that is why this sign is plus. Now 3 factorial is 6 by s plus 3 raised to 4. So we have replaced s by s plus 3. That is why it is s plus 3 raised to 4. Right? It is very simple. Now question number 3. Laplace of e raised to t cos h t. What is f of t? Yes, cos h t is f of t. So think about cos h of t first, which is s by s square plus 1, because a is 1, which is hyperbolic function cos h t. Okay, so a is 1 and cos hyperbolic, so we have to write down minus. Okay, s square minus 1, and s tends to s minus 1 because a is 1. So we will replace s by s minus 1. Okay, very good. Now this was the very important chapter. Now in next session, in next lecture, we will discuss how to find out the Laplace of t raised to n into f of t and Laplace of ft by t. Okay, in next lecture we will discuss about these two methods. Okay, thank you very much.